And that's because of the characteristics we talked about the different climates, the poor ocean circulation and anoxic conditions. And the other thing that you see, of course, is in a tectonic sense, you have two major events. You have the breakup of Pan-Africa, which is one of the early supercontinents. And interestingly, prior to this time, this is when you had Snowball Earth was, I think, 680 million years or thereabouts. Snowball Earth is interesting because that was a situation in which the entire planet is theorized to have been covered by ice. So you had sea ice over the world's oceans, not only in the polar regions, but in the non-polar regions, and certainly significant ice caps on all the continents. And something happened, and it may be, of course, that the breakup of Pan-Africa is what changed that, because when you break up Pan-Africa, that implies tectonic activity, igneous activity. As you break up the continents, you get new oceanic lithosphere form. That's related to volcanic activity, CO2 being pumped out, and so on and so forth. So it may be that this was the kind of the breaking of a long cold cycle. And then, of course, you have the growth of new supercontinents, Pangaea particularly, and of course you have low sea levels, icehouse climatic conditions. You break up Pangaea, which we've talked about, the breakup, particularly we looked in the Atlantic, as examples of extension and so on and so forth. And lo and behold, again, you're dealing with more plate tectonic activity and how this then may tie to these climatic changes. And the interesting thing about this, of course, is when you look at this, these events that change climate involve things like regressions and transgressions, and from the stratigraphy sedimentological point of view, on the large scale at least, a lot of what we see preserved in the stratigraphic record is tied to this larger picture of tectonic activity and how that tectonic activity influences climate and how the climate influences the packages of sedimentary rocks that are generated and so on and so forth. So over the last 600 million years, then we have essentially a bimodal distribution of sea level, high standards of sea level during the middle part of the Paleozoic and the Cretaceous through the Oligocene, related to greenhouse climate, obviously, and then low sea levels during the late Precambrian, the late Paleozoic, the Mesozoic, and the Oligocene to present. So we are living in, as I say, in an interglacial period of an icehouse coming. And there's this diagram again that essentially summarizes that. The upper part of this diagram, which I'm not going to talk about particularly, has to do with biotic crises, extinctions, if you will. Some of them are quite obvious. This is the Cretaceous tertiary boundary that most people tie to extraterrestrial impact objects. There's increasing evidence to suggest that probably wasn't the proximal cause, but more the straw that broke the camel's back type of thing. And if you want to tie biotic crises, the end of the Permian, the Permo-Triassic extinction, the biggest of the 6 Paleozoic extinctions, tying them to climatic change is tricky simply because when you think about extinctions, you think about them being relatively rapid, and climate change may not be rapid enough to accommodate those kinds of things. But certainly when you look at biotic crises, extinctions, climate is obviously an important factor for the biosphere. So the biosphere will interact obviously with the solid earth at that point. And if you look at biotic crises, everybody always looks for the smoking gun, the silver bullet, or what have you. And of course, the impact theory of the Cretaceous Tertiary event just has this wonderfully appealing effect because it's simple and clean. So it turns out that, say, if you start reading more detail about that extinction event, the detailed stratigraphy makes it look more and more likely that the event certainly occurred, because you've got the crater and all that kind of stuff. But the perturbation that it caused in the environment was the kind of the final stroke that did the damage to much of the biosphere, rather than the proximal cause. So we have these very large-scale cycles that may be tied to the large-scale effects of plate tectonics and how that plays. But when you look at these cycles, you recognize they're not smooth. There are smaller cycles superimposed on the larger cycles. This is like when you look at the stock market index. Stock market doesn't go up and it doesn't go down. It goes up and down, up and down, up and down to a high point, and then it goes up and down, up and down, up and down to a low point. Well, these climatic cycles or oscillations are similarly inclined. You have the first order cycles that had a 300 million year duration to them. Second order cycles, known as super cycles, have a duration of about 10 to 80 million years, that range, ballpark range. You have third order cycles, 1 to 10 million years, and then you have fourth order cycles, which from a detailed stratigraphic point of view are interesting, because it is at this level that you see the Milankovitch cycles coming into play, because here we are talking about cycles that are on the order of tens of thousands of years in terms of their periodicity. And again, you can look at this, you've seen diagrams like this. This is obviously the Phanerozoic, starting down here in Cambrian. Here are your major cycles, the first order cycles shown here, and this diagram also shows the second order cycles or super cycles, where you can see variations, if you will, on the first order. This is an old diagram. This kind of very sharp drop that you see there is now recognized to be an artifact of sampling and measuring. And I think the next diagram shows, well, it's still pretty steep, because the changes are considerable, but they tended to round them a little bit more in terms of the rapidity with which they occur. And then, like the first cycle of the previous slide, you see the first order cycles right here, second order cycles right there, and you see some global tectonic information, if you like, in this column. The breakup of Pangaea and the generation of Pangaea, maximum dispersal of continents early in the Paleozoic, and the breakup of the supercontinent Pan-African mass in the late Precambrian. And then you've got the different climatic stages shown in there like that. And these are the major sequence stratigraphy cycles that were recognized in the 1950s and 1960s, I think it was, by a number of people, related to flooding transgressions and unflooding regressions on the North American continent. So if we look at smaller scale cycles and we concern ourselves with the factors that come into play to give rise to these packages of sediment, we look at the interactions between relative sea level changes, rising or falling, subsidence or uplift, which is for the most part obviously